similar words, they are annoying. So how is spoiler alert going to solve that problem? Uh, so last month we saw the release of the most anticipated Spider-Man No Way Home, and internet was no longer a safe place for those who hadn't watched the movie yet. So what spoiler alert plans on doing is block or hide potential spoilers from the user on various social media platforms. This prevents ruining the experience for movie enthusiasts. Next slide. So initially we had planned to use an API to get the necessary data for our model. But the problem was the data we received from the API was not structured and clean at all. So due to the short time available, we decided to use a movie repository instead. So web technology, we used HTML, CSS, JavaScript to create the front end as an extension. Also used a little bit of Bootstrap 5. Our application is browser based, so all these codes become necessary. So machine learning classifier, being a classification problem, logistic regression was our first approach. But then when we checked it, it did not give us a good accuracy. So instead, we planned on using SVC or support vector classifier. We could have used other classification methods, but this one worked the best for us and gave a better accuracy than other methods. So we also used packages NumPy, Pandas. They are the go-to packages for data extraction, multi-dimensional array, operation, manipulation, and graphical visualization. We use them extensively. Cross-validation technique. So basically, it is used to achieve model generalization via hyperparameter tuning. Uh, NLTK. NLTK means Natural Language Toolkit. It was used for tokenization, stemming, and classification libraries, such as count, vectorizer, and word net lematizer. First we take an input and then we break down the sentences into words and then convert them into tokens or vectors for the machine learning algorithm. Next slide. Now I'll let Bhavya continue.
Solution. Our solution to the problem statement required us to create a machine learning model which used various optimized algorithms. The output from the classification of whether a social media post is a spoiler or not, it was passed on to the Chrome extension. Now we created an extension for browser so that the solution can be implemented on multiple websites and even other browsers. We chose this over creating an application as it is easier for the user's perspective. From user's perspective to set up. What happens is that the extension reads data from the site and the posts on social media, and then the model analyzes this input data and the prediction is given. Then the extension will inject CSS to blur the respective spoiler content using JavaScript. Next slide. So, in conclusion, our browser extension allows people to enjoy their favorite movies and TV shows without spoiling their experience through the use of social media and internet. Now, Pushkar will continue.
Yes. So for the future work, our main aim was to basically connect the front end with the back end by using the Flask. But we ended up focusing more on data analysis and using machine learning algorithms. And talking about the audio, images, and the video checking. So even they are considered as a part of spoilers. So we have kept it as a future work by using some deep learning techniques. And we even observed while performing while deployment, we saw that TensorFlow JS can be used as a pretty good model deployment application, which is very well used worldwide. And it's basically easier for the programmers or the coder to use for basically the deployment of the machine learning model. Yeah. These are all the references, and I may show the code. Yeah. Is my screen visible? Hello.
Yes, it is.
Yeah. So, so first of all, we have imported all the important libraries, like basically from the hyperparameter tuning for grid search CV. We have used we have used grid search CV. Then we even have various other algorithms which we have used. Logistic regression, as Sam mentioned, for classification, it's a classification problem. And more importantly, we have focused more on word net limitizer and count vectorizer. So even our main aim was to create a bag of words or sort of vocabulary. So these were a data set which we saw, which we got. And then this is all the reviews which we, so basically we are only dealing with the reviews column and the respective labels. So whether it is a spoiler or it is not a spoiler. So for that, everything is getting done. So we take the feature and we create a vector. So these are all the parameters, and inside that we have count vectorizer, which creates a vector. So vector is used everywhere later on in the code. So vector is basically creating a sparse matrix, which can be, we can see a bag of words, which is basically helping the model to identify whether it's a spoiler or not a spoiler. So same thing, evaluation also we have same function, and hyperparameter tuning as we mentioned. So hyperparameter tuning may we have used grid search CV, and shuffle split is basically for basically so that there is no output, so that everything is getting sorted. Is getting splitted in a proper order. And these are all, yeah. So basically vectors which we have used, normalizing it. And yeah, for the machine learning model which we are focused more is on linear SVC and SVC. So SVC we have used because we came to know that after normalizing it, the number of dimensions got increased. First approach was always logistic regression, but SVC was, after I figured it out, if SVC was a better choice as we have more number of dimensions. And for that, even after selecting SVC, we did some hyperparameter. We all got other metrics. Then these are the best parameters. Same thing. So the most important process or the most important function in this is process text. We have all the main big, all the NLP libraries which we have used here, as you can see. So first of all, word net limiter is basically used for group of words which from which we can get the root word. Okay. And by this we process the text, the input text. So basically, if there's a sentence, the Spider-Man No Way Home is, and the ending has some spoiler. So it detects that, and for that detection, we have this process text. Similarly, our main aim was to create a review text that is all the possible reviews and the labels. So labels denote the number of ones, and so basically it's a binary feature, which is 1 and 0. 1 identifies it's a spoiler, 0 identifies it's not a spoiler. So same thing we have created. This is the main data frame which we are going to use later on in the analysis. Again, transform. So here we are doing two things. In cell number 47, we are separating the labels which are spoiler. So review text which are spoiler, and in cell number 58, which are not a spoiler. So we are creating a vocabulary, or you can say a bag of words, which is having spoiler and non-spoiler. And then again, training and testing of data, and we are finding. So here, frequent spoiler. So we have used some technique called difference of frequent spoiler reviews and frequently non-spoiler reviews, so that we get a sum of actually how many are there, how many are greater than 0. So we can get there the sum. And
Sorry to interrupt.
Yeah.
Need to wind up in another minute because we are left
Yeah,
with
yeah.
the questions.
Yeah, that's it. So we are using, so this is the last thing which are using Xtrain. Xtrain is basically the training data set, and again the X test which we are using. X test we have not fitted the model. We have just transformed it and normalized it again. And yeah, this is the model which we have used. Again, evaluation of the model, and then pickling the model and testing it. So testing was the main thing which we have used it right now. So testing is this thing, inputting, giving the input data and predicting. So if it is 0, which means it's not. If it's 1, it is a spoiler. Yeah, and talking about the yeah. So basically, this is a spoiler alert extension. So if I enable this, it gets enabled here. Hold on.
On that only. The
No,
icon,
no, no,
the
no, no.
sad
It's
spot.
getting, it's hidden, I think. Tools, extensions. So it's getting activated. So sir, here my issue is the, hold on. Hold on, sir. There is some issue here. Hold on. Can I reshare it again? I don't know why it's glitching a lot. Can some of you screen share? Bhavya, anyone? Bhavya, Sam? My laptop is glitching. Sorry for the inconvenience.
Just a reminder, one last minute left, then we need to move on to the questions, or else we'll be exceeding the time.
Yeah. Sam, can you screen share?
One second, no, one second.
Yeah.
1 second.
While you're restarting, Pushkar, one question. So, does the
Yes.
extension read the data from the web page and uses the model to predict in real time?
Actually, sir, I think Sam and Bhavya can answer that. I mean, I would love to answer, but Sam and Bhavya can
The
answer
thing
that.
is, we tried doing that, like connecting both the ends using Python class, but for some reason it wasn't working. And given the limited time, we decided to then just focus our time on building a better model rather than just
Yeah,
connecting. We made the GUI and all that, but then we weren't able to connect it.
got it. So what does the extension do exactly?
So what our original plan was basically, the extension will, like whenever you open a web page, it will read through all the data, and then use Python, whatever machine learning model you have produced, to decide whether the data includes a spoiler or not. That was our original plan.
Mhm. But what does it do currently?
So, sir, we
Currently,
were unable to, sir. So, we planned on using the. We have created some files for CSS and HTML files for the procedure. Like it takes the input for the movie, but it wasn't, executing our request. So, what we were planning
Got
to
it.
was to, yeah. So that's the. But our whole focus, I totally understand the whole idea of the hackathon was to create a application or something innovative, but due to time constraint we just focused on data analysis. I mean, I don't know, like we just did our best for data analysis part and machine learning model. Yeah.
Pushkar, this is completely fine. I understand. Just was trying
Yeah.
to understand what exactly you've done, but this is completely fine. Yeah,
Yeah, thank you so much, sir.
sure.
Team, are you trying to present something, or it's done?
I
we
think
just
it's
had to show the GUI.
Sorry.
We just had to show the GUI. We haven't connected yet, so it won't be working.
All right,
Yeah,
no problem.
that's it.
So you
yeah.
are done. Right. Any one last question from the jury? There aren't any questions. We can move to the next team.
Yes,
Okay.
please.
Thank you. Thank you, team Drin Coders. It was a
Yeah,
great
thanks a
approach
lot.
to the problems.
And
Thank
you
you.
so much.
Thanks a lot.
Next, we have team ANA coming up.
Good afternoon.
Yeah, good afternoon. Yeah, you can start with your presentation.
Yeah, okay. Nilay will be sharing the screen.
Sure.
Good afternoon, judges. We are Asha
Excuse me. We'll need you to turn your cameras on, please.
Oh, yeah, sorry. We are Asha Khot, Nagatonde, and Elizabeth Fidan, with group number 3, and our group name is ANA. So, can you go to the next slide? So the aim of our program is to have a spoiler detector on forums and social media sites like Twitter, where spoilers for movies often tend to be present, especially when they're new and big event movies. Next slide. So our implementation, we implemented a solution in 3 parts. So first, we made our own comment section markup page on which we will be carrying out web scraping, so that our AI can look through the comments and then verify if they're simply reviews or have spoilers in them. We made our own page instead of, because we were not sure about the legal constraints, and we had a crunch time to do this, so we were not able to implement it on the actual website. So we made our own mockup page. Second, we carried out web scraping using Selenium library on Python. And third, we designed an engine to read through the website, to the scraped data, and trained it to come to a conclusion on whether or not it's given the given piece of text is a spoiler. That text should be hidden, warning the user and giving them the option to read the text regardless. So this is the input-output page we've written. Initially, it says a spoiler, but then when you click on show spoiler, it tells you what the spoiler is. We'll demonstrate this after the presentation. These were the technologies we used. And now Aniket will be explaining our input and output.
So as you can see, we start with the simple take and output. Over here, Nila has already typed his name and email. The sample will be testing about how it's an endgame spoiler where Iron Man dies. So what will happen? We just demonstrate like basically the back end of how the web scraping is being done and how the spoiler. So once you click on submit, use Chrome Drive to run the simulation. It will first go on Google to look for the IMDb synopsis. Right now, it automatically will search endgame, and then it will go on IMDb. The reason it's going on Google first is because our main idea with this app extension would have first been that you can type out preferences of movies you do. So then with that, IMDb doesn't have any autocorrect feature where if you type the mistake wrong, it won't be able to detect the movie at all. Whereas with Google, even if you messed up the spelling of Endgame, it will still be able to find Endgame. So after it's Google will load the plot synopsis of the movie on IMDb to check if the comment is a spoiler or not. So right now, web scraping is being performed. Data is being collected from the plot synopsis. The concept is that most spoilers end up being towards the second half of the movie. And since IMDb is a large site with a lot of information, it takes some time to load. That's why this is being slightly slow. So after it looks in the synopsis, it'll look for whether the comment Iron Man has died actually happens in the movie or not. If it has, it's a spoiler. So once it has looked, it will go back to the console and mark it as a spoiler. So as you can see, Nila is not doing anything. This is automatically scrolling through the Google Drive simulation. This is our program doing the work. Nila is not doing any of the scrolling. Right now, this web scraping is being done through the storyline. Sorry, I think we might have to run the code.
Wait, I'll just run the code again.
Sorry, it does not happen before.
Just give me 1 second. Sorry.
So the idea for our thing was we want to make this a web extension. So like right now we're using IMDb, but we could have like eventually we can easily implement the same thing based on Twitter, where again you can type in movie preferences, where it doesn't even have to be a comment. We want to make like a basically database where you can type movie preferences, but of course there is some sort of constraint with the time we have. and then again the web scraping will perform on Twitter or Instagram, whatever. Of course, it's also tough to get web scraping requests from the site instantly. Hence, we chose IMDb for now to show that if it sees a spoiler, it will go and block the message. So that Nile will run the program again and we'll show you that it does work. We'll take us back to the console.
Hello. Can you hear me?
Yes. So
Hi, I'm sorry, but for some reason this isn't responding.
okay, would you mind then if you use our video, because it was working, this has never happened before, to show that there was actually spoiling. We had sent a video right on YouTube. Till then, Nilay, do you want to explain the code and the working of it to see then if you can run it in the end to show that it does work?
Yeah, so okay, so I'll explain the working of it till then. So like Aniket said, we're basically just using web scraping on IMDb to figure out if the second half of the plot has a spoiler. So the reason behind this is like, yeah, obviously the second half of the movie of the plot will have the spoiler. Like for example, if in Endgame, Iron Man dies is in the second half of the film, so hence in the second half of the plot. Also, another parameter that we're using is the second, if there's a spoiler, the spoiler is usually present for only one line. So Iron Man dying will only be present like that one time because he only dies once. He doesn't die multiple times. So what we're doing is once we get all of the synopsis, we're cleaning the synopsis data by removing any punctuations that are there. After that, we figure out how we count the number of times a word is occurring in the entire synopsis. Once we figured that out, we take in the message that has been passed from the GUI and perform a combination of the different, like the entire sentence. So if Iron Man dies is the input that is given, so Iron Man, Iron dies, and Man dies are all the inputs that are taken. We count the number of times, for example, an Iron dies. So Iron and dies occur in the second half. Because obviously they won't occur a lot of times because Iron Man dies only once. So we figure out because there are two words, and if both of them occur once, then the highest probability that can come out will be 2. And if this criteria is met, then we return it as a spoiler, and it shows up over here. But I don't know why, but the GUI is just not working. We can show you a video of it working. I really don't know why. But yeah, so that's basically the entire code.
Try running it again, no, because we just did a dry run before this. It was working, so.
So the code that you are putting in that box, so you are basically checking if that is a spoiler or not. Is that understanding correct?
Yes.
Okay. And you're expecting that it will be present in the synopsis of the movie on IMDb, if it is true.
Yes, sir. So the IMDb synopsis is quite extensive and it covers all the plot points that have occurred in the movie. So a major spoiler that will be there in the movie will be covered in the IMDb plot synopsis.
Also,
and if it's not there, you can assume. Then you can assume that it's not a synopsis and either it's just a review or just a regular comment. Like in our testing, we have written amazing film, for example, and that wasn't present in the synopsis. So that is why it loaded immediately. And it says, it just shows the data instead of showing the spoiler.
Also, ideally, our data set would not just be the IMDb synopsis site, but the movie detail data set, which has over like 16,000 movies. And we actually went through it and saw that the plot synopses are very in detail. They cover every scene. But the reason we actually couldn't run our code on that is because it contains over 16,000 movies. So there's like a combination issue with just our laptops to run it. That running and checking everything was taking too long and we had a time constraint. So we thought we'll make a smaller database just to show that the logic of looking for the synopsis and blocking the spoiler does work. So then you can keep increasing the database. So, and then run it on different sites.
Got it. Yep, makes sense.
Okay, wait.
So now the level type is name and email ID.
So I'm gonna just type a small message like Iron Man dies and submit it. So basically, yeah. So web scraping is going to be performed now with it going through Google and then to IMDb, like Aniket mentioned earlier, because IMDb doesn't have an autocorrect feature, which Google does. So our original plan was to make this open to everyone, but because we weren't able to do it in the certain time constraint, we went through Google so that even if the person makes a small mistake in the name of the movie, like for example, if instead of writing Avengers Endgame, the person writes Endgame, IMDb might show some other movie because the IMDb API goes through its own database and not the Google database. So that is why we went through Google to IMDb and then performed the plot synopsis.
So now it's going to look for the synopsis again. Like it says, this is all automated.
This taken a bit of a time to load because I think Zoom and a lot of apps are open currently and it's using a lot of internet. Sorry.
By the time it loads, any other questions from the jury?
I mean, the work is very good. I'm very much impressed with the demo and the logic behind it. Great job. And pulling it off with such a really good.
Thank you. So I think it's working now.
Thank you. Yeah, so basically now it goes to the plot synopsis for IMDb. And so our original plan was to obviously use AIML because right now we're giving it hard-coded data of only Endgame. But our original, so we even tried doing that, but because the IMDb database was extremely expensive with only of like 15,000 movies till 2015, it had 15,000 rows. So processing all of that on just a laptop would have been extremely difficult. And then even showing it as a demo would have been okay, yeah. So you can see right now Iron Man Dice has come. Okay, sorry.
I think if you do have a video, that would be a better way to. I mean usually live demos always have some issue or the other. So I like the demo, by the way. It's really good, but make sure next time you just have a video ready so that there's no.
We have a video ready.
Can we just show you that it works?
So the same thing is happening. It types the name, email, and comment, and then on the submit action, it opens Chrome again and does the parsing equation.
The reason we keep typing this, the reason we keep typing this, OMG, I can't believe Iron Man dies, because that seems like the most realistic way of like a comment of like, oh, did anyone see this?
So right now it's thanking you for the comment and it shows it as a spoiler. When you click on show spoiler, it actually opens up the text.
So when it does a spoiler, it'll say spoiler. When you click on show, these errors actually now
I just don't know why it's not working at this point.
Yeah.
Maybe I feel like it's all the multiple apps instead of opening. It's just
too
much load because the stream is also lagging. But yeah, as you saw in the video, in the normal like dry run that we were doing, it does show, it does block the message as it says spoiler. So then we would have made this a web extension that you could put on any site. So it will start blocking messages. The full process of looking through a synopsis / database and looking for that would have been back end. Like the user wouldn't see drive simulation. That was just so a good model, so you guys can really understand what's happening and how our logic is working.
Sorry to interrupt. We are up with the time. 10 minutes have exceeded.
All right.
Okay, that was it. Thank you. Thank you for your time.
Thank you.
Reminder. Thank you for your time. And sorry, I don't really know why it didn't work.
Thank you, team. Next, we have Team BBS coming up.
The team has joined in.
Team BBH, you may start with your presentation. And I request you to switch on your cameras. You may start with your presentation.
Hello.
And I request you to switch on.
Am I audible?
Yes, sure.
Okay. So, good afternoon, sirs and ma'am. Our project is divided into two. Sorry, our project is divided into two halves. One would be the JavaScript-based Chrome extension, to comment is a spoiler or not. So first, I'll be showing you the Python script that uses natural language processing to detect if it is a potential spoiler or not. Right. So, give me. So that you see right now is the IMDb database with the plot summaries in it. Right. So this is the Python script. I'll run through the whole script. So we are using Spacey as our NL natural language processing library, right? And we are using RE to reject out the unwanted, to basically sanitize the string. So this string that is basically the entire movie summarized. The current plot is two strings attached from IMDb plus Wikipedia. So we have two databases at the same time, like two movie plots combined into one string, right? Then we reject it, and we have a final string, which is article text, right? Then we have our potential spoiler number one, which is May is aunt. Now, everyone knows May is the aunt in the movie, and that could not be a spoiler. So we have two test cases, and so the second test case is Green Goblin kills Aunt May. This is definitely a spoiler, and so even Spider-Man cures all villains is a spoiler. So we'll test the spoiler set in the second run. Then we have basically our NLP, which basically checks for the phrases. Right now, villains is over here. We could dynamically replace it. And if I were to run this once, what you would see is we have the plot that is just being printed. May, and are the two nouns that it fetches from the above string, right? And then match phrases was zero, and then therefore the length was zero, hence no spoiler was detected, right? But in it's the 4 o'clock. Sorry for that. In the similar, let's just an actual spoiler from the movie, and if I run this, natural language processing detects multiple occurrences of spoilers at the specified locations. It found 14 matches for the spoilers, and hence was detected. Right, following through this now, just to I don't know, just to play with things, let's just try the spoiler. Let's go with Peter is a boy. Not a because Peter is played by Tom Holland and he is definitely a boy. If I were to run this again, no spoiler detected. Even though the matches were found, they were not quite enough to confirm that as a spoiler, because Peter is a boy is part of the cast. That is, if someone doesn't know the cast, it might be a spoiler for him, but it does not classify as a very big of a spoiler compared to the main movie plot. Right? So this is the NLP. Then we have the Chrome extension. So Chrome extension, this would be our main file. If you check the code, we even have put the GitHub link up and the zip file. Spoiler categories controller.js and element marker controller.js is we're using JavaScript to basically in real time check Chrome and then block the divisions that have the spoiler content. So the data these will be the data that we get from the user. So I'll show you that also. But for now, if you see friends, if I load the page up with friends, let's just open a new tab to confirm. Friends, nothing gets blocked for now, right? But I give the users the option to append categories for themselves. Let's say Friends was released obviously like in 1994, as you see over here. There may be chances where someone has not seen Friends, and even though a lot of time has passed and everyone has seen, you could manually add friends in your so this would be the Chrome extension web UI. Okay, so you could manually add friends to your spoiler list that you don't want to see any spoilers regarding friends. And let's say the spoilers should not definitely have Ross and Rachel in it. because that was the big lead, right? And then you can simply add that as friends is the name of the category. It is an English show and it is a TV show, right? And then we would simply add it. VBS spoiler alert, new category added successfully to the system. Okay, so now if you see, it has automatically blocked any spoilers that it found, which would include Ross and Rachel in it. Which obviously it's a tree data structure. So friends is the main word keyword, and then any spoilers regarding Ross and Rachel are blocked. So over here, so if I were to quickly just search for spoilers of Friends, right? Even in the search, it manages to block that as well, right? Right now it shows flash spoiler because I have a subcategory. I'll just delete that quickly. Right. So Friends spoiler. Right. So if I were to click this spoiler alert, Friends reunion reveals the Ross. So this has a spoiler in the title itself. So it is automatically blocked if you see. Right. And then what we have over here is, sometimes you don't even want to know what spoiler is it. So we could just simply turn this off and we would just see it's a friend spoiler and does not specify the subcategory. Is it a Rachel spoiler or Ross spoiler? We could manually just block out words if we wanted. Let's say I just don't want to see a specific word. So it will just find that string on the entire web page. So let's say I don't want to see the word Ozark, right? Ozark has been added to the list. If I were to just search for Ozark now, you can see it has automatically blocked this this thing that I did right now, that this does not use any NLP. Right? It just finds Ozark in the entire web page and blocks all the places where it found Ozark. Right. So I will just delete this quickly for now. Right. So now we have categories covered. We have spoiler keywords covered. Right. What I would like to show you is this doesn't only work on Google. Even if you go on any other site, like let's say you go on Twitter, because it just uses the divisions and the strings to find data. Now, if I were to search Game of Thrones, because if you see, I've added Game of Thrones as a category already. If I were to search for Game of Thrones, right, wherever it could find Game of Thrones and any potential spoilers regarding the same, it will automatically block it, right? So here it automatically block it. Yes, sir. So that would be it for our presentation. So the Chrome extension and the natural language processing, over here, model, not a model script basically. So the advantage of having the script is that we do not have to train it. It would in real time just get the data from the web script or from the JavaScript, and it would just figure it out if it's a potential spoiler or not.
How are you detect? I mean, so what technique are you using to classify if it's a spoiler or not?
So basically, I have the IMDb movie data set where which I've reduced it right now for testing, but it had 15,000 movies in it. It would basically get the movie from, because we specified categories, like I specified Friends over there. So it knows that it is from Friends show, right? And then it would basically search for the plot of that thing. Sorry, this is the wrong. It would basically search for the plot for that thing and use natural language processing using Spacey to search to verify that the string, that is the comment which could get replaced over here, is a part or makes sense with the movie plot.
Got it. Yeah, makes sense.
So basically, instead of training the model and to retrain the model every time, we just do it in real time. So there is no pre-need to get the model trained or no computing power required, because natural language processing can be done quickly, right? If we wanted, we could obviously train a model out of this, giving the agent rewards and stuff. But in the time that we had, this was the fastest approach that we could come up with.
Mm-hmm. Makes sense.
So just to reconfirm, you are not using any model, you are doing some kind of pattern matching, right? Or string matching.
Natural language processing has its own training pattern. So yeah, if you would consider the libraries training model, then it would be a different thing. But right now there is no. So I definitely tried building the model. I also started building the model on my own. If I were to show you that as well. So I was loading the JSON file into this, and I created an observation space, and the state was false at start, and if it were false, it would get true. But
Like
I'm not.
what you did over here, you took that sentence and you have a corpus and you try to find a match, right?
Right. So sorry, I
Thanks.
didn't get.
So
This
I
model
said,
is not there in the system. That's why I did not show you. But it would basically give the agent reward if it was a match or if it was a potential spoiler or not, and then that's how the model learns. The agent learns.
We can take one last question from the jury. Any more questions?
The idea of using a reinforcement learning model for the spoiler detection is very innovative. Whatever you had planned to write but did not write. I would recommend one thing. See, Kaggle has got a lot of reinforcement learning competitions which will be there. You'll have some geese competition which happened last year. And there were other things, Hungry Geese. Yeah, it's a Nokia game, and you'll have several other competitions. Head on to those competitions if you want to like build on this. Head on to those competitions. You'll have multiple agent sample codes which you can quickly use it as a prototype and build upon it within a few hours. And maybe for the next hackathon of similar type, if you are going to if you want some prototype which you can quickly edit the code and use it, then I would recommend that. Otherwise, like with the time given to you, but something which you can show, demo itself is a great thing, and a great job. I'm very much impressed.
We even
Thank you so
planned,
much.
like right now, if you told us about reinforcement learning. So this is using the PPO approach, right? The proximal policy approach, but the optimal would be using Manhattan. But I didn't have the time to go through all the understanding of Manhattan. So I knew PPO beforehand. So I was like, let's just start using PPO for now, a DQ and the DQ neural network. But Manhattan would be the optimal approach, is what
There are a lot of sample codes for not just reinforcement learning. For these kind of problems, you have a lot of sample codes. I'm just listing out Hungry Geese because I was planning to attend that competition myself. But if you go for any of these competitions, Hungry Geese, the latest one is months. And before that also there were like few other competitions. The name is just not coming to my mind, but you will find like these kind of competitions in Kaggle at least 3 to 4 a year. I think they started from. So you will find sample code almost for everything, DQNN and lot of things. You'll find sample code for everything. So you might have like 100 to 150 codes to start with. So that way you will save lot of time, writing anything from the scratch. So that is something which I would highly recommend. But the whatever models you will find there, they require a lot of compute power, and they also require a huge number of days of training. We did not win any medal, but we just tried something, and that even the trial, the kind of compute power we wanted was like 64 core CPU, and we wanted very high end GPUs, and we were like training for 6 to 7 days, and then we gave up because of the GPU constraints earlier, and we moved on to some other reasonable competition. But you will find the winner solutions very interesting, and these are solutions which can be adapted to any competition. And so I would highly recommend go and check that out if that interests you, and for especially for hackathons of this format, writing something from the scratch might be really difficult. So you can use that as a template to do something on top of it. Yeah, but whatever you did was okay, good.
I'll definitely check that out. Thank you so much. Thank you.
Thank you, team.
Thank you so much for your time.
Thank you so much. Hope you have a
Next, we have team VMITs coming.
See, I have a hard stop now. Is it okay if you can share the recording to me so that I can evaluate it? Is that okay?
Yes, ma'am, we'll get on that.
Yeah, you can share the recording, the video, right? You can share the recording to me and I'll evaluate it. Yeah, okay. Okay, then
Yes,
I'll
ma'am,
just
we'll get in touch with you. Thank you.
Yeah, sure. Thank you. Bye.
Team MITs is in. You can start your presentation.
Yeah. Good evening, everyone.
Also, turn on your cameras.
I think, am I visible to you?
Yes, yes,
Yeah.
you're visible.
Okay, great. And apologies from my teammate. She is actually tested positive today itself. So she is just present here for the presentation. So she will not be able to, help me in the presentation or keep the camera on.
That's okay. She can take this. You can continue it by yourself, right?
Yeah.
Yeah, please.
Okay. So this is what we have made, Spoiler Protect by Team Vimities. The abstract around which we built this problem was the marketing technique which new series have come up with to actually create a FOMO within the audience and promote their content in such a way that the whole social media is flooded with their informations, reels, memes, and videos related to them. The problem with an individual relating with all of that content is when the person has not watched the content. And that's where the problem arises. It creates a FOMO for people to actually go and watch the series. And that's how that's actually the goal of the company to create the marketing funnel. So the key problem that comes in here is someone who is even interested in watching the series, let's say after a week if it is launched, they are able to get some of the spoilers from the social media which serve as a negative impact and act as a demotivation for the individual to go and pursue that series because they now have the reference to the exact climax or the what we say is spoiler to the series. So what we are looking at, the solution that we are planning to develop is not an antivirus, but which protects you from spoilers, not from the virus over the internet. So our solution as this detection of potential spoilers. We are using BERT model for it. Uh, Let me share my terminal. Okay, I hope this is visible. Okay, so what we have, we were not able to complete the whole GUI part of it, but in the backend, what we have implemented is we have again, other participants that have participated, we have got the IMDb database, and if we are matching it with the reviews currently, we if in the similar fashion, it can be extended to other text pieces as well using the web scraping problem. So just a second. Once we enter a file, we have to enter its movie ID, which IMDb database has assigned to each and every movie. That we do, and then it creates and indexes the file and the reviews that are collected with it. So if I evaluate what we then have is the weights that are attached to each review, which actually show the degree of them being a spoiler. So this is actually taking up a review, which is again from the data set of IMDb, and it is actually evaluating it on the base of spoiler it could potentially contain. So I guess that was mostly our presentation. Around this is actually giving a score, giving the non-spoiler count, spoiler count. It is all doing it using the LSTM model and trying to make a degree of how much spoiler there is potentially. A threshold could then be set, uh, taking in mind the number of posts that are coming on social media. So,
could you please reshare your screen?
Pardon?
Could you please just go back to that terminal screen?
Yeah.
So what's this score? Is this score for a document, for a comment, or what?
This is for a review.
For one review, whether it's, it's a spoiler or not.
Yeah.
And what were the numbers that were displayed below that?
It is
Scroll
basically
down.
just, yeah.
Yeah, these numbers. What are these?
Just give me a second. These are basically the weights that are being attached of the degree of the spoiler that they could potentially be. So it's taking in multiple reviews and analyzing them.
So each row is for one review?
Yeah.
Okay. But the score that is being displayed, that is mostly same, right? 1.1 followed by 5, 6 zeros and then some.
Yeah. Unfortunately, we could not train it much. So there is not a good output efficiency. Ideally, we think after doing further research, we think the ideal model that we should have used here is the BERT model.
Okay, sure. Thank you.
Any other questions?
Could you please share the code base ones? Go to evaluator.py. Just hold on. Scroll down. Got it. Thank you.
Anything you want me to,
No.
Okay. Any other questions?
I don't think.
Okay.
Thank you,
Thank you
team.
so much. Bye.
Moving on to the next team, we have Team GDS coming.
The next team is in.
Team GDSC, you may start with your presentation.
All right. Is my screen visible?
Yes, it is.
So very good morning, good afternoon, actually good evening now to all the judges and all the panelists within the meeting. So we'll be presenting our extension, a Chrome extension that we made, which is called Spoiler Smasher. So going over going over the roadmap of this presentation, we'll be starting with the problem statement, our view of it, our solution, our research, what our research, what we included with the research, the tech stack that we use, and what makes us stand out. Also, there are how we saw the problem and how we fleshed it out is something we'll be covering a little bit later. We weren't fully able to implement it, so we'll talk about it a little later on. So, talking about going over the problem statement, the problem statement was to construct a model which blocks potential spoilers on social media platforms. So, our view of it was not just to make an AI model. See, since and the problem with an AI model for specifically for detecting image spoilers in images or videos is that the feature sets for detecting any sort of a spoiler within these sort of media is not there. So there isn't any common feature set within these sort of media to detect them with a model. So the only model viable was for detecting spoilers within text. So going over it, our solution was to first select a data set, which we selected the TV source data set and the Goodreads data set, as well as the IMDb spoilers data set, which we finally trained the model on. We did a pre-processing of data, which was basically creating tokens for using the BERT tokenizer, training and comparing. So comparison we did it with the Manhattan LSTM, the ESIM LSTM, and SVC model. So for evaluation, we obviously we go over evaluation in a bit more depth. Then finally, we deployed it as an extension, Chrome extension, with a Flask backend, and for the front end, we used HTML and JS, HTML, CSS, JS. So in depth, a bit more in depth about what we have done is we have selected the IMDb spoiler data set, reprocessed the data, we used transformers library to get a board to that model and use it as a classifier. And basically the output which we get is we basically feed in any review, feed in any
Excuse
review,
me.
pre-process the data. Yeah.
I apologize for interrupting. Could you please go over the implementation along with the theory? So
Okay, so we used a BERT model, but for a BERT model, we used the transformers library. Transformers library, along with that, we trained it on the IMDb spoiler dataset. Also, we used the BERT tokenizer to create tokens with indexes for the data each review. So then parsing each data. We're passing data from HTML, sending it back to our Flask backend, and creating tokens and sending it to the model, and the output is then blurred out within the output is in searched and blurred out within the HTML in the DOM. So our research, so our model the comparison between the models which we did, the accuracy which we received was a lot better than what was there available online. So what is BERT? Going over BERT, it's built over the transformers framework, and basically it adds an implementation where it adds an extra feature that it can process text from both sides, from the front and the back. That's the entire transformer framework of encoders, attention, and decoders is all there. So text stack which we use HTML, CSS, JavaScript, jQuery, Python, Flask, and Deeper. So HTML for the front end for the Chrome extension, CSS for modifying both the creating the blur effect and also the CSS of the pop-up for the extension. JS for handling the scripts for sending requests to the backend, get for hosting the model, and deep learning BERT model which we use for classification. So what makes it stand out? The ease of use. So it's literally just a Chrome extension which you can install easily, and it provides us high accuracy and is highly efficient. So the future scope, the main idea which we were going for, which wasn't fully implemented, so this was only part of the idea. The main idea was to create a system where a user can easily report with the architecture. So we only implemented this architecture partially. So the main idea was to create not just a model for AIML model for converting text to for detecting spoiler in text. It was also to through an OCR, also speech to text, you would detect text and images and videos. That was one part of it. There's another part of user contribution to it. So this was for video. So this was for let's say videos without without conversations or images without any text, which would still provide spoilers. So for that, we would have a user. We would basically follow this algorithm, which is a user would a user would have an ownership over a spoiler which he would
So
report.
Angad, sorry to interrupt. Could you please show us a working demo?
All right.
Like we are short on time.
All right. So this is the browser. This is the extension that we made. So this is a page where we found a lot of spoilers for movies and all. So we'll be using our using the Chrome extension to weed out the spoilers. So there's a bit of computation time, but the it is pretty highly accurate. So it has successfully detected spoilers within these pieces of text. Also, it successfully successfully blurs out all these spoilers within the text. So this is just the implementation of it. You can also toggle it off on hover. You can also basically get it back. On hover, you can actually just leave the text normally. So this is one of them. Also in a similar page.
So just to is it passing the page in real time, sending the
Yes,
text to the model, and then the model is predicting, the word model is predicting whether it's a spoiler or not, and then you are blocking content.
Yeah, I can show you in that writing.
Okay.
Successfully detects. So this is what's. So this is the basically the tags which have been found to contain the text which was actually containing spoilers. So we use the selector jQuery selector to find each and every element which contains this tag, and then we apply CSS blur to it. We add the class blur text to it, and each of these basically becomes blurred. So that's the entire idea behind it. So these pieces of conversation actually contain spoilers within them. So to block them out, it has successfully detected those, and this actually entire thing is basically supposed to be a conversation chain which contains spoilers of different movies, and it has successfully detected it and classified it as spam as spoilers. So this is our idea behind it. So the extended idea behind it was actually to have a user more of a. So see, no one see the in this in normally people don't use these types of applications. So to incentivize users to use this, we came up with an idea of monetizing users. So monetizing in a sense of creating an NFT based on the user ownership of a report. So if a user, let's say, reports a spoiler, he can then claim ownership of it. This can then be supported by other users. So let's say a user has other users support it. So any view it gets would provide it further more credit, and also the supporters further more credit. But that same report the ownership of it would get negative views and negative support as well. So let's say it receives negative support from people. So that way it would lose credit rather than gaining it, which would harm it and also incentivize proper also like properly marking out spoilers as
But for that
properly
to
reporting
work,
spoilers.
sorry, Angad, to interrupt. But for that to work, the first user would have to actually go through the spoiler, correct?
That's right. That's right. But
Asha,
that would create a system that would incentivize people to
I actually have a
use
question regarding the model that you have showed us. In your model documentation, you had mentioned AUC score also, I think. Can you just verify what the AUC score was? That's the only question I have.
So, all right. So Soumya here would explain a bit more about the model. Soumya.
Jury, this will be the last question we'll be able to entertain. We'll have to move on to the next team after this.
Yes, sir. So you were asking about the AUC score of this model, right?
Yeah.
So I had drawn the graph, but I have got 62% of the AUC score for the while after training it on the test data.
Okay.
All right. Any further questions?
None from my end.
All right.
Thanks.
Thank you, Team GDSC. It was a great presentation. Next, we have Shubhankar Mistry as a participant coming up for his presentation. Shubhankar, you may start your presentation.
Can I start?
Yeah, you may start.
This is my presentation.
We cannot see the screen. Can you please screen share?
Where is the option? Can you see?
Yes, it's visible.
So could you please turn your camera on?
Okay.
Yes, please go ahead.
This is my presentation. Can I start?
Please begin, yes.
Huh?
Yes, please start.
Okay. Good evening, ma'am. My name is Shubhankar Mistry, and I do this hackathon on weather shouting unpredictability in C language, in advanced C language. These are my outlines, and these are the contents: introduction, methodology, description, diagram, program, and conclusion. These are my 6 contents. My project consists of these 6 parts.
Shubhankar, I'm so sorry to interrupt you. What is the problem statement that you've referred to for this event? What the solution that you've made is for what problem?
Weather shouting.
I'm sorry, you were supposed to create a program that will detect spoilers, movie spoilers. Have you done anything in that regard? Anything related to that?
Movie spoiler?
Correct.
No.
All right. I'm afraid you had to only solve the problem statement that we had presented you with. I'm sorry, you won't be allowed to continue with your presentation.
Okay. This is my presentation.
Yeah, we understand that and we applaud you for your effort, but only the problem statement that the organizing committee had given you, the one you had received in your email, was the one that you had to make a solution for.
This is not a solution.
This is not a solution for the problem given you to solve.
Okay. But this is related to shouting. No?
It's okay, Shubhankar.
Yeah, someone from our organizing committee will get in touch with you shortly. The next presentation till then.
Our next team is Tech Rivals. And this will be our last team for the advanced.
They are in. Like they are joining.
Okay.
Yeah, they are in.
Team Tech Rivals. You may start with your presentation, please.
Yeah, okay. Uh, so I'll be doing the presentation because actually my teammate, he has a bit of a sore throat, so he won't be able to speak. Can I screen share?
Yeah,
Yes,
please go
yes,
ahead.
please do.
So this is the spoiler detector model by Shrejan and Vishesh Sharma. So first we'll talk about the database. So the database will store images, key phrases, keywords, and videos from latest movies, TV shows, web series, etc. Information from the database will be removed once it is 3 months old, and new information about the latest movies and shows will take its place. The database will be divided into 3 sub-databases. So that will be text database, which will store keywords and phrases, image database, which will store the pictures, and video database, which will store the videos. In blocks and sectors, each sector of pixels depending upon the resolution of the image. For example, an HD picture which has a resolution of 1920 times 10 into 25,920 sectors, each of size 80 times 80.
Shrey, can you please move on to the implementation of your code and side by side explain the theory?
Yeah,
Because
we're
have a
gonna
time
get on.
constraint of 10 minutes.
Yeah, no, this will get over in 10 minutes.
Okay.
So videos will be stored as separate frames and not as the entire video. And the keywords and key phrases will be stored in a list. So now we'll talk about the procedure. When a new post is made by a user, before uploading, it will be compared to the information in the database. If the match is successful, it will be marked as a spoiler and the post will be blurred. The viewer of the post will be told that the post consists of a potential spoiler and will be given an option to unblur it. Different types of posts will be compared differently. Therefore, there will be 3 different situations when comparing the post to the information in the database. Text comparison, if the post is in the form of text, It'll be tested against the value stored in our text database. If the match is successful, the post will be blurred. Image comparison. If the post is an image, then it will be compared against the image in our image database. Instead of the entire image, each sector of the image will be compared with the sectors of another image. This way, even if two images don't completely match, but some of their sectors do, it will be considered as a spoiler and blurred. For example, if the post contains a picture of Spider-Man that does not directly match with any of the image in the database, but the sectors that make up the image of Spider-Man will be tested against sectors of images of Spider-Man in our database. And if they are similar, then they'll be marked as a spoiler. So if it's a video, then it'll be tested against the videos in our video database. Instead of comparing the entire video, the frames of the videos will be compared with each other. If the frames in the video are the same as the videos in the database, it will be marked as a spoiler and blurred. So this way, we don't need to store a large number of videos because even if the frames are similar, the post will be marked as a spoiler. Also, video comparison will be more time consuming compared to frame comparison. And if somehow our program fails to detect a spoiler, the viewer of the post will be given an option to mark it as a spoiler. If it is marked as a spoiler by more than 10 people, the post will be marked as a spoiler by our program and thus will be blurred for any new viewer. So here we have a simple spoiler detector in Java. Basically what it does is there's a list of keywords. This is only an example. We can add much more. And the user will enter whatever post he wants to do. And like using this code, the individual words and phrases in the post will be compared to the keywords. And if it is true, then it'll be blurred. And if it is not, then it'll display that the post is spoiler free. So for example, the output of the program in such a case will be, if the enter your post, in the new Spider-Man movie with Spider-Man's identity now revealed, our friendly neighborhood no longer able to live his normal life as Peter Parker. So this contains like Spider-Man and movie. So this post consists of a spoiler and will be blurred. Thank you.
Working demo where you can show us what you showed us on the slide?
No.
Okay.
Any other questions for the team?
None from my end.
All right then. Thank you, team. You may leave now.
Thank you.
So we've concluded all the presentations. Thank you so much, jury. Your patience throughout the duration of the presentations has been really inspiring and reassuring. And we are glad to extend our sincerest gratitude to you for the same. We look forward to a chance of collaborating with you again in the near future. And we hope that this experience has been just as enriching for you as it has been for us, it is the organizing committee and the participants. Thank you so much.
Thank you. Thank you for having us.
Thank you so much
Thank you so much, sir.
for your presence. Thank you.
Thank you.